And one thing we have to talk about is energy densities. Basically, how many miles can I go? Well, how many miles can you go on what? It's going to call it a gallon of space. So, if you have your vehicle, and here's your vehicle, and in here you have a fuel tank. Now let's say you have, make number simple, you got a 20-gallon fuel tank. Now if you have a 20-gallon fuel tank and you get 20 miles per gallon, basically 20 times 20 equals 400. 20 miles a gallon times 20 gallons of fuel is 400 miles you can travel in that tank. In this case, we're talking about a tank of gasoline. But the real thing I want to bring to your attention is this is 20 gallons of space. This is 20 gallons of space that your fuel is taking up right now. Now, what would happen if you replaced this liquid fuel tank here with cylinders of compressed gas? How far could you go? I'm going to show you some basic rules of thumb. If you had a vehicle, here's our vehicle, here's our same 20 gallons of space. Only instead of a fuel tank made out of plastic or metal, we're going to put into here, we're going to put cylinders. And these cylinders are going to hold, in this case, methane. What's methane? Natural gas. Now this cylinder is compressed to about 3,000 pounds per square inch. The rule of thumb is that this natural gas will take you about 1/3 of the range as gasoline. This is not because it's more or less efficient. We're talking about an engine that is running on what's called a homogeneous charge, a normally aspirated homogeneous charge, which means if this is the air intake to the engine, as we've been drawing, you have a throttle body in here. And this throttle body is limiting your air intake. And you're spraying the gasoline in here, and you're going through the normal 4-cycle charge as we explained back here, okay? So this is not taking into account any efficiency gained in hydrogen or anything else. This is just BTU of methane versus BTU of gasoline in a normally aspirated homogeneous charge engine, which is the car you go down to the dealership and buy today. This will go about 1/3 as far. Why? Well, this gasoline is a liquid. This is a gaseous product. Hard to say. You don't want to say it's a gas, I don't want you confused with this. This is a gas like the air you're breathing. And this is a liquid. Even at 3,000 psi, this has less BTUs per square foot, per gallon, per unit of space than the gasoline does up here. This is at 3,000 psi. So you go about 1/3 the range. So 1/3 of 400 is going to be about what? Get your calculators out. If you can go 400 miles on a tank of gasoline in the same amount of space without adding more tanks back here. Notice on buses they like to put them up here. Without adding more tanks, that means you're going to go about 133 miles on the same amount. Now, hydrogen. I love it when people say hydrogen. It scares me. Okay, here's our vehicle. Here's the same amount of space as here. We're going to put H2 in here. And this, again, is going to be at 3,000 psi. The rule of thumb is that you won't go 1/3 the distance, you'll go about 1/10 as far as you did in the gasoline. So it's not 400 miles with hydrogen at 3,000 psi taking up the same amount of space. It's going to be 40 miles. Doesn't that make you happy? Yes, I am saying if you put 3,000 psi tanks into your vehicle, you take up the same space that the gasoline tank did. You will go 40 miles on 3,000 psi hydrogen in a normally aspirated homogeneous charge engine as you did, you went 400 miles in a gasoline vehicle. Now, what's changing some of this? Some of this has changed a little bit, both in terms of the DVD you're watching and technology available. This cylinder for both the methane and the hydrogen is 3,000 psi. It is now very common to see 5,000 psi tanks easily available. What does that mean? Well, you're going to go 5/3 as far as this 133. So this might get you up to about 170, 180 miles on the tank. Now there's also 10,000 psi cylinders available. Yeah, you can go buy 10,000 psi carbon fiber tanks. You might have a hard time finding a compression place that will give it to you 10,000 psi, but that'll change as well. It's year 2005 right now. You could be listening to this in year 2010, and these are very available, so are the compression stations. So since this is about a little bit more than 3 times more than this, basically if you're at 10,000 psi, you'll end up going the 400 miles on methane like you did on gasoline. So same thing over here. Instead of going 40 miles, you're going to end up going somewhere between 120 and 150 miles at 10,000 psi. Pretty cool, huh? You want to know something? Like I said, material science is changing all the time. Once we get above 40,000 psi, hydrogen is going to be at about the same volume density. You're going to be going as far as you were up here. Now, I'm saying 40,000 psi, you must be crazy. Well, they said the same thing about 5,000 psi 20 years ago. They said the same thing about 10,000 psi 5 and 10 years ago as well. And we are here today. Our material science just keeps on improving all the time. So these are your rule of thumb. That's why you see natural gas and hydrogen vehicles with a bunch more tanks on them. They'll cram more here, they'll put them in the back of the vehicle, they'll put them on top of the vehicle, they'll try to fit some more underneath here. They'll put them wherever they can. They'll take up the trunk space and the cargo space and the roof space and do everything they can to give them more miles per gallon of space. You know, one of the really good things, like I mentioned, you see buses with the tanks up here. It's available space on a bus, and they got the whole top roof to put it up there, and it makes it real easy for that bus to go a long range on natural gas. So anyways, those are some of the rules of thumbs of tanks of gas and tanks of gas in a vehicle.